Hold on.
You're recording.
Now you're recording. Oh, damn.
Looking good.
Dude, this is like a cool picture.
I know, you're looking good.
I was not expecting that.
It's a knack for you.
Okay, so I was just talking to Paul for like 5 minutes. And so, first of all, what is the outcome of this session? The idea is to solidify my current understanding of chemistry so that I can apply it further to what I am going to do to eliminate carbon, identify carbon negative fuels, i.e. making a plane out of a solar cell, or making a plane fly through a solar cell, or overall just helping Mars fly and developing better space fuels. Because there are three, those sound like two different things. My primary objective is Virgin Earth. My secondary objective is to get our ass to Mars. I'm totally serious. I'm absolutely serious. Okay, so what is I don't know. I was on a roll with Paul earlier. Normally I do these things through screen capture, and I capture like what I'm reading and what I'm not reading. And recently I learned a few things. I learned the idea of an aromatic compound which contains a benzene molecule, which is basically 6 carbons with 3 of them as a double bond. This is useful because I don't know yet. The aromatase, or all I know is that an aromatase molecule does something to your hormones that's bad, and what I do remember is that aromatase inhibitors actually help you to boost your testosterone, regulate estrogen levels, and balance your progesterone and estrogen count if you're a woman. But so yeah, I was trying to. That's a pretty interesting point. That's to do with biochemistry. That doesn't have to do with rocket fuel or deleting carbon dioxide. Period. Deleting carbon dioxide could be a tough one, and it might require future technology with, say, the Higgs boson particle, or just better knowledge of quantum physics, or things like quarks and subnuclei. I don't know these things yet, so if you can't break apart a carbon naturally or with another element, or if you can't break apart carbon dioxide with a normal element, then you're probably going to have to go subatomic, which will get intense. So anyways, I learned about the aromatase molecule, which includes the benzene molecule, and I learned how to identify methyls along each of the along each carbon group in the benzene. So if there's a methyl on the 1 and a methyl on the 2 carbon chain, which I could show you when I get an animator, I'll get to show you, but that's too complicated without a visual explanation. But like there's right now there are 6 carbons here. Each tip of my finger has a carbon on it. If you have a methyl here, which is like an extra, like 2 carbons where my middle finger is, and a methyl here, that is a ortho. And right now I'm just telling you what I learned. The application of this is unknown to me. All I know is that it can make a radically different compound, like the exact same number of carbons and various molecules will be different if the 2 methyls, which is a carbon and 4 hydrogens, are here versus shoot, I gotta master my fingers. Alright, it'll be different if they're here versus if they're here versus if they're here, or like the thumb and the middle finger, or the thumb and the middle finger. Because their quote-unquote dipoles are different. The charges on either end is different, and it affects the density. It affects the boiling point, the melting point, the freezing point, the molecular mass, the total molecular mass of the object. And The last one was actually one that I wasn't sure of. When, as I said it, I'm thinking that it could be unique. Anyway, that's enough for now. I'll talk a little bit more about this soon. And that's it. Recorded from a MacBook Pro. And Apple is the inventor of computers, by the way.